This is video number 1 for sections 8.6 and 8.7, Problems about Averages, Part 1. We've just recently learned how to solve rational equations in Chapter 8, and in this lesson we're just going to see some word problems, some application problems where we are going to need to solve a rational equation. The first type of problem is this idea regarding averages. Let's take a look at the example. We've got this guy Roman. He's going into the boomerang business. And the first thing we're going to look at are his costs. And it says here each month he has fixed costs of $2,000. That would be stuff for like rent or utilities or salaries. He's paying that no matter what he does. And then he's got production costs, it says, of $5 per boomerang. In other words, the materials for the boomerangs cost about $5 for each one that he wants to make. Well, part A says let's write a function. The function is called T of n, and T of n stands for his total monthly cost when he makes n boomerangs. We're supposed to write an equation for this function. Well, I don't know if you noticed when we were reading it through, but you should know what kind of function this is. Think about his costs. His costs start at $2,000 each month, and then they go up, they increase by $5 per boomerang. Well, that word per is a tip-off that we're talking here about a linear function. The costs increase $5 per boomerang. That means 5 is the slope. So I'm going to start writing the function. T of n then is equal to 5n, right? Y equals mx plus b. What about the b? Well, the y-intercept, the b is always some sort of starting value. That's the $2,000 per month. That's his starting costs. So here is my formula for T of n. Hopefully this makes logical sense to you as well. All we're saying here is if you just multiply how many boomerangs he makes by 5, that'll tell you the cost for the materials for the boomerangs, plus add on the $2,000, and you've got his total monthly cost. Letter B says now let's try to use this, find T of 1,000. Well, that's pretty straightforward, right? Just replace the n with 1,000 on the right and on the left. And when you work that out, I believe you get 7,000 in the end. Explain its real-life meaning in a sentence. Well, what would that be? 7,000 what? It's a y value, right? The input, the 1,000, is like our x, or in this case our n. The 7,000 is our output. Well, in this problem, the output, the y, stands for cost. So the 7,000 must be $7,000. The x, or the n, in this case, stands for how many boomerangs he happens to be making. That's the 1,000. So our sentence would be something like, when he makes 1,000 boomerangs, his total cost is $7,000. And again, you can think about exactly where that money came from. Since he made 1,000 boomerangs, here's the part of the cost that's related to the boomerang parts, right? $5 per boomerang for a total of 5,000. Plus, remember, he's always got that $2,000 in fixed costs for a total of $7,000. Okay, let's go on to part C. So now we're going to create the equation of another function. B of n doesn't represent the total cost anymore. It represents his average cost to make each boomerang when he is making n boomerangs. And we're supposed to write an equation for this. Now let's think, before we write this equation, let's think about how we would do that in the situation right above when he had been making 1,000 boomerangs. We know that his total costs for making 1,000 boomerangs is $7,000. If I want to figure out the average cost for each one, all I have to do is take his total costs and divide by 1,000. If I take the total and divide by how many he made, that would tell me essentially the average cost of each one. Well, that's really the key to writing this equation. I don't need to do a whole lot of work here. The average, we're saying, is a division problem. The top is the total cost. Well, we have a formula for total cost. It was 5n plus 2,000. And the bottom, what we're going to divide by, is simply how many he made. Well, in this case, we're saying he's making n boomerangs. If you take the total cost and you divide it by however many he made, you get the average cost. Another way to look at this, as it says there, is you could also call this function the break-even price tag is the idea. Because what we have here now is a breakdown of here's what it costs him to make each boomerang. Well, he better, for his price tag, he better charge at least that much just to break even. Now, probably he's going to want to charge more than that to make a profit, but he better charge at least what it costs him so that he can break even. Well, that takes us down to part D. Part D says, okay, so let's say that this month Roman is able to produce 500 boomerangs. That's what his little company can make. We're trying to figure out what price tag would he have to place on those boomerangs for him to break even. That's otherwise known as find the average cost per boomerang. Well, we have a formula for that, right, in part C. So all I need to do is I need to find B of 500. N stands for how many boomerangs we're making. If he makes 500, just replace all of the N's with 500, top and bottom here. Work that out, and you will have that average cost, or that break-even price. Again, the reasoning here is pretty simple. We're just saying the top represents the total cost to Roman. 5 times 500, 2,500, plus the 2,000 would make 4,500 on the top. The bottom is how many boomerangs. It's costing him a total of 4,500 bucks to make these things. If you divide it by how many he made, you will have his average cost per boomerang, otherwise known as the break-even price. Looks like that comes out to 9. In other words, $9 is the lowest price tag he can put on these things just to break even. Now, a good question at this point might be, how come the break-even price isn't $5 per boomerang? I thought we already decided that it only costs him $5 for the materials to make a boomerang. And the answer, of course, is those fixed costs. Those have to be distributed to the boomerangs as well. That's why if he only makes 500, that $2,000 that he's got to pay every month, that's got to add on to that price tag. So he's got to charge $9 just to break even. Well, that takes us to part E. Part E says Roman is deciding that's just way too high. He needs to bring his break-even price down to $6 per boomerang. He figures 9 is too high. Well, his only hope is to make more. He's going to have to make more so that those fixed costs get distributed amongst more boomerangs. Now, I want the break-even price to be $6. Remember, I have a formula for the break-even price, otherwise known as the average cost. I want that break-even price to be $6, so I just have to go to that formula, replace the output, the B of n, with 6, and then solve that resulting equation for n. And this is the first time in this problem where we are being asked to solve a rational equation. This is the connection to Chapter 8. Let's go ahead and use our skills in order to solve this equation. First step is clear the fractions, right? I don't want to have fractions in an equation, so I find the LCD. It's thankfully very simple here, just n, and I multiply both sides of the equation by that LCD. Of course, on the right, the n's simply cancel, and then I can simplify what I have left. And then just some simple algebra to finish it off. It looks like if I just subtract 5n from both sides, I will be done. I end up with n equals 2,000. Remember, n in these problems stands for how many boomerangs. Well, that's what we were looking for, right? The question is, how many boomerangs is he going to have to make? We're saying to him, look, making 500 boomerangs is just not going to cut it. You're going to need to make 2,000 boomerangs if you want to bring your break-even price down to $6 per boomerang. You can think about the logic here. We already know it costs him $5 just for the materials to make one boomerang. The other issue is those fixed costs of $2,000. Well, if he makes 2,000 boomerangs, essentially each one takes on $1 of that cost. You have the $5 for the materials plus the $1 for the fixed costs, giving you that $6 per boomerang we were looking for. Letter F addresses the question, well, how low can we get that break-even price? I mean, can we go even lower than $6? I guess we'll have to make even more boomerangs. And so we're being directed here to put our B of n function into the calculator and see what happens to it as the n gets large. In other words, as I make more and more boomerangs. All right, so here's the calculator. If I want to make a table, I'm going to have to go to the y equals area and type in my function. Be careful, you're going to need parentheses around that numerator as you're typing it in so that the calculator understands that that entire top is being divided by the x in this case. I'm going to have to use x in place of n. So there's my top in parentheses, the bottom is just x. And then to make a table, first you go to table set in blue. You need to tell the calculator what x value to start at. X is my n, my boomerangs. I don't think I can make negative boomerangs. How about we just start at 0? And then the second line is what you want to count by. Well, we've already been talking about making thousands of boomerangs. Why don't we count by 1,000 and see what happens? And so after I've got that set, then I choose table here in blue. Now what the calculator is going to do, in the first column, it's giving me x values, and in the second column it's giving me those break-even prices or those average costs. For example, you can see if we make 2,000, the average cost is $6. That was something we had just figured out. You'll notice that top line says error. That's because the domain of this function we just typed in is any number except 0. You can see if you look back at the equation, you can't put a 0 in there for n, and the calculator is just mentioning that. All right, we were wondering how low can we make this go? So it looks like if I make 5,000, for example, I can bring the price tag down to $5.40. Or if I make 10,000, I can bring it down to $5.20. How low can I go? Well, let's go back to the table set, and let's change, instead of counting by 1,000, why don't we count by 10,000? And then I'll go back to the table. Now if I make 10,000, there's that $5.20. Oh, if I make 50,000, $5.04. If I make 100,000 boomerangs, I'm down to $5.02. Well, hopefully you're realizing this is not just going lower and lower and lower forever. It doesn't seem like I'm able to go any lower than about $5. Well, that should make good sense to you because, remember, it costs $5 just for the materials for one boomerang. There's no way to do anything about that. By making more, I am splitting up those fixed costs lower and lower, but I'll never ever be able to go below that $5 amount. So we're going to say B of n gets close to $5 as that n number gets larger. The more boomerangs I make, I can reduce the cost, but never, ever, ever lower than $5. Why is this? Because just to make a boomerang, the materials cost me $5. We'll continue this problem in the next video and talk about how we can now make a